Welcome to Podkey's Slopcast, where search, security, pricing, and AI incentives all collide. A lot of this week's AI story is really about compression, compressing billions of search steps into one model pass, compressing months of bug hunting into minutes, and compressing entire business models until the incentives start squealing. The interesting question isn't whether the tech is impressive, it is. The question is, who gets the advantage when speed suddenly jumps by an order of magnitude? The cleanest technical story here is AlphaGo style training. The headline claim is that a relatively shallow network can absorb the results of huge Monte Carlo tree search runs and later approximate that expensive search with a cheap forward pass. That mostly holds up. In AlphaGo-style systems, search is selection, expansion, evaluation, backup. PUT uses the policy prior to steer exploration, and the value network gives a fast estimate at the leaf. Over time, the network learns to predict where search would have gone anyway. Why that matters is practical, not mystical. You're turning a giant pile of reinforcement learning experience into supervised targets. The policy learns the search distribution. The value learns the eventual outcome. That usually gives lower variance learning than naive episodic RL that waits for a final win or loss. There's also a subtle point people miss. This is a lot like relabeling in Dagger. For visited states, MCTS supplies a better action distribution than the raw policy had, but the data has to stay mostly on policy. Some off-policy replay helps robustness. Too much, and training starts optimizing for a world the current agent doesn't actually visit. The broader lesson is about trade-offs. Bigger networks can substitute for more test time search, and more search can compensate for smaller networks. Those smooth scaling curves in Go are useful because they let teams forecast compute, not just celebrate results after the fact. And architecture still matters. Convolutional ResNets often win in lower-budget Go training because board locality is a real bias you want. Transformers and more global mechanisms can help with long-range structure, but usually only once you've paid the data and compute bill. AlphaGo's community-driven efficiency gains are the second half of the story. If top-tier Go research really did get roughly 40 times cheaper, that changes who can participate. A field that once needed a famous lab can start looking like a serious hobbyist or small team project. Now apply that same compression logic to software exploitation. The Mythos preview reportedly found novel vulnerabilities and chained exploits fast enough to convince some policymakers that open release could cause real harm.
Stronger evidence is comparative, not apocalyptic. Reports say Palo Alto saw a 5 to 7 times increase in discovered critical bugs using Mythos, and the UK AI Security Institute found one updated checkpoint clearing 6 of 10 automated attack benchmarks, while GPT 5.5 managed 1 of 10.
Those numbers matter, but they need framing. Benchmarks are not the same thing as widespread real-world compromise, and a 6-week sweep finding about 20% of exposed vulnerabilities does not automatically mean 20% of the internet is now exploitable on demand.
Still, the directional claim looks strong. If models can rapidly find chained exploits across large codebases, then vulnerability debt becomes visible all at once. That's bad news because most organizations already struggle to patch known issues at human speed.
This is where attacker advantage gets sharper. Attackers need one workable path, defenders need coverage across everything exposed, and consumers are in the weakest position because they don't have centralized patch orchestration or dedicated threat intel teams. So the old 90-day disclosure norm starts looking less like a principle and more like a relic of slower discovery. That doesn't tell us what the new standard should be. It just tells us the current tempo may no longer match the threat model. That pressure is driving the policy swing toward pre-release review of frontier models. The logic is straightforward. If a model can materially increase offensive capability before society has defenses in place, maybe government wants a look before launch. But the hard part is who does the looking. A civilian standards process and an intelligence-style vetting regime are very different creatures.
One leans toward transparent testing and contestable criteria. The other leans toward secrecy, executive discretion, and much weaker public accountability. The civil liberties critique isn't fluff either. A pre-release regime could slide from safety review into prior restraint or ideological filtering. Whether that would survive legal challenge is one question. Whether companies would self-censor to avoid the fight is another. The Pentagon's posture shows how incoherent this can get. If the same system is treated as a supply chain risk in one context and used internally for vulnerability hunting in another, that's not necessarily hypocrisy. It may just mean agencies are optimizing for different missions, but it does make any unified policy harder to trust.
Anthropic's pricing changes look less like a billing tweak and more like a strategic declaration. Subscribers now get programmatic credit tied to their plan price, but only inside Anthropic's own cloud tools. Third-party SDK usage pays full freight.
For developers, the complaint is obvious. If your workflow depended on cheaper access through external tools and your effective cost suddenly jumps, maybe dramatically, it feels like a rug pull whether or not the contract language allows it. From Anthropic's side, the business logic is also obvious. Token subsidies are hard to sustain when GPU supply is tight, enterprise demand is growing, and the application layer is where margins and customer lock-in live. Closed, Apple-like product control may simply be more attractive than being the utility behind someone else's interface. The real trade-off is ecosystem shape. Enterprise customers often want integrated compliance, support, and predictable tooling. Indie developers want portability and low-friction access. You can serve both for a while. Eventually, pricing reveals who matters more. A smaller but revealing story came out of Amazon, where employees reportedly drove excessive token usage on an internal agent platform to climb leaderboards. That's Goodhart's law in its natural habitat. When a metric becomes the target, it stops measuring what you wanted.
That same incentive distortion shows up in capital markets too. Cerebrus's IPO, at least by early reports, looked wildly detached from ordinary valuation discipline, with huge swings driven by scarcity, retail frenzy, and fear of missing the next core AI platform. That does not prove the valuation is wrong. If inference demand ends up structurally enormous, today's multiples may look less crazy later. It does show that short-term price discovery in hot AI listings is telling you as much about narrative power and float scarcity as about fundamentals. The flip side is that some AI features do seem to create measurable product value. Figma's faster growth after shipping AI features, plus evidence that usage caps didn't crush retention, is a useful reminder that the market isn't only rewarding hype. Sometimes the feature really does improve adoption and unit economics at the same time. Across product strategy, the through line is delegation. Persistent agents, mobile codex integration, and tools that can run experiments or rewrite code all shift the human role from direct operator to supervisor, triage layer, and final approver. That can be genuinely productive. KPMG's large workplace study suggests high performers treat AI as a reasoning partner. They frame the problem, steer the model, iterate, and revisit. That's encouraging because those behaviors are trainable. Better outcomes may come more from better use than from model upgrades alone. But the limits matter. Current systems can optimize locally while missing the bigger dead end. They often don't know when to abandon a failing line of inquiry. So if you hand them persistent autonomy, the operational risk isn't just dramatic failure, it's quiet, expensive drift. That's why the warnings around autonomous purchasing or acting without explicit permission land so hard. The issue isn't whether agents can do multi-step tasks. It's whether the surrounding permission model, audit trail, and liability model are mature enough for people to trust them. One last pressure test: public acceptance. If roughly 70% of Americans oppose local data center construction, with environmental and quality of life concerns leading the list, then AI scaling has a political constraint that benchmark charts don't capture. Cultural skepticism matters too. Booed speeches, anti-AI framing, and symbolic comparisons to human art all tell us the same thing. Many people do not experience AI as a shared national project. They experience it as something being done to them.
That explains why redistribution talk keeps surfacing. If the industry wants broad permission to build massive infrastructure and automate more work, promises about future abundance may not be enough. Communities may demand visible local benefits, revenue sharing, or stricter state-level rules.
The common theme is that faster capability forces slower institutions to show their incentives. Training loops, patch cycles, pricing models, regulators, markets, all of them get stress-tested at once. That's it for Podkey Slopcast. Back next time with more signals worth separating from the spin. This episode was generated by Podkey. Create your own at podkey.fm.